Content are introduction, types of flexural failure, prevention, construction practice. Introduction. Prestressed concrete (PSC) beams are commonly used in a bridge and building construction. Flexural failures in PSC beams can occur due to the various reasons. Understanding the types of flexural failures is crucial for designing and maintaining safe. Types of flexural failures. There are three main types of flexural failures of PFC beam: brittle failure, ductile failure, and shear failure. Each type of failure has distinct character, implementation, and structural integrity of the beam. Let's explore each type flexural failure in detail. Brittle failure. Brittle failure in PSC beams is characterized by sudden and catastrophic cracking. It often occurs when the concrete reaches its ultimate compression strength before the steel yields. Brittle failure can lead collapse of beam without warning, posing a significant safety hazard. Ductile failure. Ductile failure in PSC beams involves gradual deformation of cracking, in providing warning signs before ultimate failure. It occurs when the steel reinforcement yields before the concrete crushes. Ductile failure allows for some degree of the deformation and energy dissipation, making it as a more desirable failure mode compared to the brittleness. Shear failure. Shear failures in PSC beams have happened when the beams failure due to the it's more common shorter. It's more common short. Off ಆಯ್ತು ನಮ್ಮನ್ನೇ ಪವನ್ ಹಾಳು ಮಾಡ್ಸತ್ತು ನಿಂಗೋಣೇನಾ. Shear failure. Shear failures in PSC beams happen when the beams fail due to diagonal tension exceeding the shear capacity of the concrete. It's more common in shorter spans and heavily loaded beams. Shear failure can lead to sudden unexpected structural collapse if not properly accounted for the design. Causes of flexural failure. Flexural failure is in PFC beams can be caused overloading, poor construction practices indicate design to the material. Defects indicate the prestressing for the improper detailing and reinforcement can also contribute with the flexural failure. Understanding the root causes of the failure is essentially for the implementing preventing measures and ensuring the safety. To prevent flexural failure in PFC beams, proper design consideration, material selection, and construction practice are crucial. Advocate prestressing force, appropriate reinforcement, detail, and regular maintenance can help mitigate to risk of failure. Structural monitoring and timely repairs for the all also prevent. Design consideration. During the design phase, engineering must consider factors such as span length, loading condition, and material properties to prevent flexural failures. Proper distribution for prestressing for force and reinforcement along the beam length is essential for the ensuring structural stability. Advanced analysis techniques and computer simulators can aid the preventing flexural failures. Material section. Selecting high quality concrete with advocate convincing strength, durability, property, and essential preventing flexural failures. The quality of the properties of prestressing steel also play a significant role in the structural performance of PSC beams. Using corrosion-resistant material can increase the longevity of PFC beams and reduce the risk of the failure due to the material gradation. Construction practices. Proper construction techniques, including the accurate placement of reinforcements, can carefully handling precast elements and effective prestressing producers are critically for the flexural failures. Monitoring and quality control during the construction can help identify potential issues early on the prevent structural differences. Training on the supervision of construction personnel are essential to ensure the best practices of following during the construction of beam. Maintenance and inspection. Regular inspection of maintenance of PFC beams are necessary to detect the signs of distress of deterioration that could lead to flexural failure. Non-destruction testing methods such as ultrasonic testing and visual inspection can also help us the condition of PFC beams without any causing damage. Promote repair of a crash, spalling, or other defects. Prevent further deterioration and extend of service of life as PFC beams. Case studies. Examination Real world of case studies of flexure failures in PFC can provide valuable insights into the cause of consequence of such as lessons learned from the past failure and inform to the future design, construction, and maintenance practices to prevent similar indicates. Case studies highlight the importance of true analysis, quality control, and protective measures to ensure the safety and integrity of PSC beams. Conclusion: flexure failure in beams poses a significant risk to the structural integrity and safety of bridges, building, and infrastructure. Understanding the types of flexural failure, their causes, the prevent measures in essential during this maintaining resilient PSC beams by implementing proper design material construction practice and maintenance protocols. Engineers can mitigate to the risk of failures and ensure that performance of BFC beams. Thank you.